Hi there. Welcome to another interesting session on AI agents. Let me kick off things with a quick fact. Did you know that AI agents are expected to add a massive $16 trillion to the global economy by 2030? And in healthcare alone, 90% of hospitals are expected to adopt AI agents by 2025, transforming patient care in the way we can't even fully imagine yet. Now, today's session isn't just about understanding some technical details of AI agents. Instead, we are going on a complete journey right from the core concept of AI agents to their practical implementation in real world scenarios. Along the way, I'll be demoing you a solution called SentryMind, which I developed to show how AI agents can use for fraud investigation in a bank. This will give you a concrete example of how these agents can transform process like fraud detection and compliance reporting. So stay with me till the end. By the time we are done, you will walk away with end-to-end perspective on AI agents, how they work, how you can start building them from the real world use cases. With that, let's dive right in. Let me walk you through how the AI agents function in the real world setup. At the center of it all, we have AI agent, which acts like a task expert. This means that the AI agent specializes in executing specific tasks by leveraging multiple components. It all starts with a user prompt, like providing query. The agent takes its prompt and orchestrates the necessary action to deliver the result. The AI agent can fetch the document from variety of sources, both structured or in unstructured data, like a vector databases, semantic search, or doing a regular query. And then based on the input and the context, the agent breaks down the query into actionable tasks and execute them in sequence or parallel. For understanding and generating the language-based output, AI agents can use a powerful LLMs like GPT or Anthropic or Mistral or DeepSeek. So beyond language, the agent can also work with the machine learning based models for a specific predictive task or a deeper data analysis. The AI agent is working alone. It connects with various tools and sub-agents, each designed to perform a specialized action like fetching external data or performing calculation, generating a report. This is the difference between the regular traditional based microservices or APIs or app and agents. Here, the agent is able to determine what tools to use based on the user prompt. If user says compare my product with the other products which are available in market, it knows that for this particular prompt, I have to do a web search. If the uh, prompt says that I want to know the features of this product, then it knows that it has to go and look into the internal database, any vector database, to get the features and display to users. So the agent is able to decide what tools to use based on the user prompt. That's a key difference between traditional way of developing a applications versus the AI agents. Now let's quickly understand our use case. So we are having a fictitious bank called SentryMind. So we are going to see how the SentryMind bank can actually use AI agents to do the fraud detection and fraud analysis. That is the key thing about AI agents. We need to have a proper business case, business scope defined before we can actually dive into the agents. What is the agent is supposed to do? And we are not boiling an ocean by one agent doing multiple things. Each agent is supposed to do only the specific task assigned with a specific tool set. Then if at all you're having multiple things, that's where you have multiple agents, and then you need to have the collaboration of these agents. Now, let me introduce you the SentryMind Bank use case. SentryMind Bank is a financial institution focused on detecting and preventing fraud while ensuring compliance with the global regulations. So, fraud detection is critical for banks to maintain operational integrity and meet regulatory standards. So, there are several common types of fraud we focus on this use case. Something called structuring, when a large transactions are broken into small amount to avoid reporting threshold, like instead of $10,000 I make like 9,900, 8,900, like that. Then something called layering, which involves moving money through multiple transactions or accounts to obscure its origin. Then we have offshore transfers, where funds are transferred to foreign accounts to evade detection and scrutiny. The fraud detection process typically starts by monitoring a real-time transaction for a suspicion pattern. The transaction flagged, analysts conduct detailed review to determine if it needs to be reported to regulatory authorities. In case of a confirmed suspicious activity, a suspicious activity report must be filed. So our goal in this use case is to leverage AI agents to automate and enhance this process, saving time and reducing human error while improving the accuracy. Now let's look at how our AI powered agent helps streamline this fraud detection and compliance process at CenturyMind Bank. The agent works in several steps to ensure a comprehensive analysis. So it first fetches a transaction. There is a one agent that retrieves all the flagged transaction from a transaction database. It then passes on this to another agent called fraud pattern analysis agent. This agent then scans a transaction for fraud patterns such as structuring, layering, offshore transfers using that ML model. This step helps to identify whether the activity is suspicious or not. So we are using something like XGBoost model, ML model for this. The next step is compliance checks. Then the agent check if detected patterns meet the criteria for regulatory reporting such as filing SAR. Now if required, the agent automatically generates a detailed SAR report. This report includes transaction details, identified patterns, and summary of why this transaction was flagged. This helps the compliance team at quickly and accurately identifying the transactions. So by automating these steps, the agent reduces manual effort, ensures consistent reporting, and enhances fraud detection accuracy. This makes compliance faster and more reliable. Now let's dive into each step. To kick things off, let's start with the most crucial step, identifying the data required for our fraud detection compliance. Having the right data is essential the AI agents to effectively analyze transactions and ensures compliance to regulatory standards. So for this use case, we'll be working with multiple data sources. The one called transaction data. So we are using a synthetic transaction data to simulate real world scenarios. The data set includes transactions IDs, amount, timestamps, account details, the transaction types. It forms a core data set the AI agent will analyze for potential fraud patterns. Now, next we are having some documents like FATF recommendations document. This document contains guidelines from the Financial Action Task Force on combating money laundering and terrorism financing. These recommendations are global standard for identifying suspicious activities, ensuring financial compliance. Then we are having SAR electronic filing instructions. This document from the Financial Crime Enforcement Network provides detailed instructions on how to prepare and file a suspicious activity report. It covers reporting threshold, transaction types, and filing standards, key details that agent will use to determine if the SAR filing is required. Then apart from that, we're having CenturyMind Bank internal document like the playbooks, or if the fraud happens, what is a playbook? What is the threshold to check for a particular transactions? What is the protocols? What is the escalation mechanism? So these are all the document required for the agent to make a decision. So by gathering these data sources, we ensure that AI agent has a comprehensive context understanding of the regulatory landscape, enabling detect the suspicious activities and generate accurate compliance reports. This sets a foundation for the rest of the process. The next step is data pre-processing and storage. So we do the data cleaning. That means we have to clean the data, remove any special characters, merging, transforming the data. Then we chunk the data into smaller chunks to be able to retrieve easily the chunk. For example, if I have a query I want to check on the structuring, then I need only chunks related to structuring from the FATF recommendations or from internal playbooks. I don't want whole context. So I'm going to chunk the documents and then store them in the and then create embeddings and then store in vector database. So why we are doing this? So that when we have a right uh, fraud type detected, we won't retrieve only the documents chunks related to that. We are having a huge repo of document, like each document like 50-60 pages, 100 pages of document, guidelines, the playbooks, internal reporting standards. So, and then from out of all these things, we should retrieve only as part of the document chunks which are required for our particular fraud type being investigated. Now that we have prepared and processed the data, the next step is to build a machine learning model to classify a type of a fraud involved in each suspicious transactions. Our goal is not to just detect whether a transaction is fraudulent, but determine what type of fraud it represents. For example, structuring, layering, or offshore transfer. So we approach this multi-class classification problem. Here is a process. So we start by identifying the objective, classifying transaction distinct fraud type. Next, we do the data preparation. The raw transaction data is clean and pre-processed. We create a set of features that can help the model distinguish between different types of fraud. The next most important step is feature engineering. This is an essential step where we derive the meaningful features from data. For example, sudden spikes in transaction amount can indicate structuring, while a cross-border transfers are a strong indicator of offshore fraud. Then we choose a model. In this case, I am choosing XGBoost model for its high accuracy, speed, and ability to handle multi-class classification tasks effectively. XGBoost can identify feature importance, helping us understand what patterns are most predictive for each fraud type. So this model is trained on the labeled transaction data with each transaction tagged with the correct fraud type. We then optimize the model by fine-tuning some hyperparameters to get the best possible performance. So now after training this model, we need to evaluate its performance to ensure it accurately classifies the fraud types. Since this is a multi-classification problem, we rely on several key metrics. Precision. This tells us how many of the transactions predicted for each fraud type are actually correct. For example, if we classify 10 transactions as a structuring and only 8 are correct, our precision is 80%. Recall. Recall measures how many actual instances of each fraud type of our model successfully identify. Higher recall means we are having fewer false negatives, which is crucial in fraud classification. Then we have F1 score. This is a harmonic mean of precision and recall, providing a balanced measure. It's useful when we need to strike a balance between precision and recall across multiple fraud types. Now we are also having AUC, also area under the curve. The measures the overall performance of the model in distinguishing between a different fraud type. The closer the A is to 1, the better the model is at classification. So our objective is here is to achieve high precision and recall for each fraud type while maintaining a good balance across all classes. This ensures that model effectively support fraud analyst by classifying transactions with a high degree of accuracy and confidence. So now we're the final step, which is building the agents. So we have one agent which will retrieve all this transaction related to a particular customer from the database. It will pass on this information to another agent which will go through each transaction, classify the transaction as what type of fraud, structuring, layering, or offshore transaction using that ML model we developed. Now there is another agent which will take this transaction data from first agent, the inference, the classification, the fraud from the second agent. It also pulls the internal document like FATF recommendations or internal playbook guidance. It gives all this information to an LLM model like GPT or Anthropic, and then asks the model to do a full analysis or final analysis. Here the most important thing is that the LLMs oftentimes will hallucinate. That means they might assume certain things which are not in the fact. So that's one of the reason we are making sure that, and in case of a fraud detection and analysis, we should not have any hallucination. That's one of the reason we are doing this two-step process. We are first categorizing the transaction as a fraud types. We are giving all the internal guidance related to that document. Now we are giving the full context to LLM and asking it to classify. Now in this case, LLM has got less chance to hallucinate and then provide an analysis which might be deviating from the guidelines or the playbooks or from the actual fraud classifications. So this ensures that we have a two-level control, like one agent actually doing classifying the model based on the pre-trained data, and then LLM is taking that input along with the guidance and playbooks. So we ensure that there is no hallucination and the analysis agent making is accurate. Okay, let's start the demo. So before I start the demo, I want to show you the data we are using, one important thing. So we are having a transaction data which is structured, which is being loaded into the MySQL database. There is a Python script, you can clone the repo and then try it on your own, which will generate a million records for a particular, simulating variety of fraud scenarios. And we also having customer data, and we are also having a training data. There is scripts for to generate synthetic data for each of them. And we are also having a lot of unstructured data, one of them being FATF recommendations on anti-money laundering, and then the bank might have their own anti-money laundering and KYC compliance. The bank has got their own internal fraud investigation playbook, and then the bank has having their own SAR reporting guidelines. So all these documents are chunked and loaded into the Pinecone database using this particular embedding model. Right now, we have a transaction data. Now we have the unstructured data loaded into the Pinecone database. We can also, as I told, we also have a model called XGBoost model trying to recognize the patterns in the fraud. So for that, there is a notebook. You can take this notebook, you can train this notebook, retrain the notebook on your own data. One of the important thing is that you need to look is check for all these features, like this is very important thing. We need to do all the feature engineering, like having all the real transaction amount, number of transactions last 30 days, number of layering up in last 30 days, whether the transaction between 5,000 and 9,000 is the destination is Cayman Island, destination Switzerland or Panama. Basically all these features will help the model to try and understand that a particular transaction is fraud or not. Now we are actually flagging this is the label data. What it means is that when you actually a transaction happened in the real time, there is another ML model might have flagged this transaction as fraud or legitimate. Now we are doing a deeper analysis to find what type of fraud happened and what type of like the structuring or layering, and they're doing deeper analysis. Now going back to this application, the way the flow works is the bank employee will actually search for the fraud transaction happened between a particular day, between particular time of the day. So we are searching for all the fraud transactions in this date range. So I'm going to get all the fraud transactions. Now I can see the account numbers, their name, the account type, total fraud transactions, the fraud amount. Now I'll pick up one of the fraud, like for example, there is a lot of fraud. Maybe I'll pick up this one where 10 fraud transactions are there. Then when I click on analyze, this is actually going and retrieving the last transactions for this customer, and then categorizing each of the transactions into the different fraud categories, and then passing on this data along with the internal data like I showed, like FATF recommendations, the compliance document, the reporting guidelines to LLM, and asking it to deeper analysis and decide whether it requires a SAR reporting or not. And yeah, this might take a few couple of seconds to minutes, because it has to do a large amount of processing. It has to retrieve, it has to go to LLM and then get all the data. Once all the data is done, this will be we will have the report being generated. So yeah, it is taking time. So yeah, now it has finished the analysis. A report has been generated. Now we can go and check whether the reports. So now we can see that it has generated report for all these customers. You can pick up on the customer. It prints the overall analysis on the fraud happened. It also identifies the transaction status, and that's one interesting thing. We are doing deeper analysis. When this transaction happened, maybe the one of the model might have transaction this as a legitimate, but when you do deeper analysis, it is saying this transaction is not flagged as fraud. However, the predicted type is structuring, which involves making multiple small transactions to avoid reporting. So basically the model, the initially, even though it escaped, this was not actually caught, but during deeper analysis we are actually, categorizing this as a fraud. And then there could be, it actually gives you a individual analysis for each of the fraud scenarios, like, like why it is a fraud, what type of fraud type it is, it happened, what a fraud happened. So like that, the now based on this, the bank employee will decide to file SR reporting. Then they can use the data, this analysis, this transaction details, the fraud types, to file the SAR reporting. So this is about the Sentry Mind. Yeah, we can enhance this app to add a more filtering, and maybe add additional features like generating a PDF out of this report, or maybe integrating with other systems to record the report. Yeah, we can also extend this application with all the other features. Okay, thanks for watching the demo. Hope you enjoyed it. Please leave your comments, and I look forward to seeing you again in another session. Thank you.